Hi, my name is Andrew Boardman, and I am the Executive Director of the Haskell Foundation. If you are here, it means you have reached my talk on historical futurism as it relates to the Haskell programming language. So, what does historical futurism even mean? It's obviously a contradiction in terms, right? Well, futurism was a movement that basically glorified modern accomplishments, and its followers believed that the path to liberating ourselves from past mistakes was to focus on the promise of the future. Thus, historical futurism is simply futurism that balances driving towards the brightest future we can imagine while staying grounded in historical understanding. For Haskell specifically, this means reflecting on our past, examining the present of Haskell and the industry at large, and then challenging and inspiring our current and future community to create and implement new vision of the future. And that, my friends, is historical futurism. So to find our brightest future, we start by going back to the dark times. The year is 1988, and our intrepid hero has a brand new copy of Turbo Pascal 5.5. After learning some syntax and trying out a few projects, I have come up with a project to challenge myself, writing a text editor for my bulletin board system that I've been running out of my family's second landline for the last couple of years. As it turns out, text editors are deceptively tricky pieces of software, tracking where you're doing word wrap, how that interacts with the user's cursor, inserts versus appends versus deletes. There are just a lot of fiddly details to get right. But Turbo Pascal has given me a secret weapon as of version 5.5 so that even I, a high school student learning this on my own, can figure out enough of what I'm doing to see what's going on when my code is running, making it easier to add features and fix bugs. Interactive debugging is a great explorative tool, not just for solving problems, but seeing how the code actually functions against real data. I can see what values my variables get when things go right and when they go wrong. And I can deeply understand how it is working. For a beginner, writing my first program that other people will be using in a real setting, that connection with my code made the difference between being an actual self-taught working programmer and not. My success was directly proportional to the quality of my tools. But back to our hero, who is off to a land of pointy-headed academics, Carnegie Mellon University, theoretically class of 1994. While I'm getting used to my new undergraduate life, I see on a physical bulletin board an open position for a research assistant in the business school. And they want somebody with Turbo Pascal experience. Yahtzee! Yahtzee was a game where you roll a bunch of dice, and if all 5 of the dice were the same number, it was a Yahtzee. And so like this was a really unlikely event to happen. And then so yeah, I'll move on. This was fantastic, and it was a great fun time. I had a ball being good at Pascal, and I could make changes to the research code while learning how token ring networks work, how to make and apply genetic algorithms, simulate markets, and more. And interesting tidbit about token ring networks, if you unplug the wire at the wrong time, the token ring will fall out, and then they're really, really small, so you have to go looking for them. It's a real pain. At one point, there was even talk of flying me to Barcelona to help a collaborator there. For an 18-year-old, this was amazing. But I got distracted by a shiny thing called C++. At this point, it is a preprocessor that outputs C, and there's basically no tooling beyond what C does. And the symbols are all weird because of that preprocessing. And I'm playing with this on the main campus system's Unix machines, not the DOS machines that Turbo Pascal is on. So I end up taking a huge step back in terms of tooling. But I'm really interested in learning object-oriented programming, and I'm really interested in learning this new language, C++. I'm now doing literal printf debugging, and I'm reminded of the comparison to figuring out where your dog has gone during the day by following a trail of droppings. Droppings indeed. I wanted to learn, though. I want to learn. So I forgive the regression and tools and I forge ahead, even convincing my boss to let me create a new trading simulation platform in C++. Fantastic. What could go wrong? I was certainly full of myself and sure of my abilities, but I lost connection to how integral the IDE had been for helping me understand a new language, a new system that I was building from scratch. Before, it was a text editor. Now, it was a market simulator. Honestly, the ratio of wacky stories to time actually spent at Carnegie Mellon is totally crazy pants for me. But we need to move on, so I can't tell them right now. The thing that I want to emphasize is that my second foray into writing a new piece of software from scratch for others to use failed. In one case, I had tools that were supporting me, and in another, the tools were adequate if you already knew how it all worked. By contrast, around this time, Haskell is gaining more traction, coming out with versions 1.1, 1.2 of the report. In 1994, John Peterson registers Haskell.org, and it gets hosted at Yale, which is where Dr. Sunder, my research professor, eventually gets tenure. Coincidence? Yeah, absolutely. But is it? Yeah, 100%. In 1995, let's fast forward a little bit, I'm walking into my first job after getting my degree, and they tell me I'm now a Macintosh programmer on a team with a mix of Macintosh and Windows. I had not programmed Macintoshes before. My family had had one of the first generation Macs, but in terms of programming, the most I had done is like HyperCard. This is the before time, when source code control was relatively new and relatively rough. And here's what we were doing at this company. We had a master build computer, which sounds like a Tron thing, right? And it had the golden version of the code. In fact, it had multiple golden versions of the code because when you needed to patch a previous version, it had all the previous releases on it as well. And you might have to do your patches in those multiple releases, depending on what was going on. Let's say I had a change ready and tested locally. Now my job is to merge those changes onto that master build computer's copy. I need to claim the semaphore. One of the senior developers, Kevin Murray, wrote his own diff tool based on some research that had been done at the time, and I used that to get a list of all the changes that I had made to my local copy of the code. I put that on a floppy. For the younger people out there, a floppy is a old way of storing data, not very much data, and it was like a physical thing. Walk to the master build computer and run the tool to compare my changes against the master version, which probably has more changes made to it by other people since I made the copy to my local computer. This process is tedious, it's manual, and it's extremely error prone as I figure out how to merge each individual change. Once I'm done, I start a build, and if that build is successful, I move the ant over to the build computer's cubicle wall, signaling that the next developer can grab it. First come, first served. Near deadlines, grabbing the ant is a full contact sport, and it doesn't help that the fewer changes other people have made since you made your own copy of the code, the easier the merge will be. Not only that, but we have a team working on a Windows port of the Macintosh code, and they haven't even put their code into the master build computer yet. So to solve these issues, we worked on adopting a new tool. We switched to Visual SourceSafe from Microsoft, and the transition was not smooth. We have epic corruption issues, which make some of the members of the team, especially the senior ones, want to go back to how we used to do things. In the end, and even with those significant problems, the productivity gains we get far outweigh the problems. Newer versions of SourceSafe deal with the corruption and other bugs, and we have a source code control setup that can scale, at least for the size of the company. It also allows better collaboration between teams working on different products, which have previously been completely separate with different processes. Even though members of the team have put serious time and effort into the tools to make the old processes smoother, some had resisted the change, investment in the new tool was the right choice and made the team significantly more productive. Once again, our success depends on the quality of our tools. Hello? Hello, can you see me? Am I on? Haha, haha. I think I did it. I think I hacked into my old talk from Haskell Love 2021. All right, that means you can see me. Hi, I'm Andrew Boardman from the future. And honestly, you won't miss the rest of my talk from back then. It was kind of a snooze fest. I don't have a lot of time, so save your questions until you understand the full gravity of the situation we're dealing with. Things are bad here in the future, really bad. And we have to figure out how to fix it. We did in the future, but we were too late. I need to tell you what we did so you can do it sooner, okay? The key is to shorten the time, shorten the cycle between when people come up with an idea and when they can test it. Software ate the world, which means making software development more efficient is the key, and that's where you come in. This is the critical point you exist in right now. Please do not throw this opportunity away like we did. We have so many problems. Climate change, pandemics, you're in the first one still, right? Natural disasters, social upheaval. We were too slow to address it all, and we've suffered for it. No more time to lose. Let's dive in. You'll come up with different solutions. That's the nature of different timelines. But the reason that I'm interrupting my lame talk is that you're at a critical juncture. Everything is lined up, making it possible for a quantum leap in productivity that only the Haskell community can make happen. It's September of 2021 for you guys. Brett Victor's influence has been felt. All you need to do is refine and expand it for functional programming. He said that the goals of a programming system should be to support and encourage powerful ways of thinking and enable programmers to see and understand the execution of their programs. There is so much power in lazy, pure functional programming, but accessing that power can be a very painful process. The work you do in this programming system will help both beginners learn faster as well as experienced programmers accelerate their productivity. Right, Victor. Another gem of his was a programming environment is a user interface for understanding a program. Especially in an environment for learning, the environment must be designed to explain. You adorable residents of 2021 think programming environments for learning are all Khan Academy. But what is maintenance of an existing code base by many different engineers over time, but a constant stream of professionals needing to learn the legacy code, understand how it works as well as possible, and make modifications that work within its context? Programming is constant learning. Working with a lot of developers is a process of teaching and learning and trying to set them up for success. For that matter, what is technical debt but code without the context that teaches what it does, why the design choices were made, and what alternatives were considered? It is giving an answer without showing the work, so that the next person that needs to understand why that answer was chosen has to repeat all of that work of figuring it out again. Joel Spolsky wrote an article way back at the turn of the century, April of 2000, where he compared programming with mental juggling. You're keeping all these details up in the air in your short-term memory. And if you get interrupted, they all fall apart. The time and effort to get them back up in the air is harsh. A good programming environment needs to do as much of that work for us as possible. In your timeline, you set up terminal windows and partition your screen with Emacs or Vim or VS Code, and that helps. But all the effort that you put into your setup only helps you. And it would make no sense to a new programmer. We're not leveraging all that effort to make things better for all Haskellers. In a talk Victor gave in 2017 about computers as an artistic medium, he pointed out that their strength is in simulation, not being a digital version of paper, ink, punch cards, whatever. This is even more true when we're talking about changing the runtime behavior of the computer itself. Looking at static text files rather than a simulation of the runtime of what we're programming, it's kind of absurd, don't you think? Punch cards were used for most of the 20th century, and programmers and companies built amazing tools and workflows with them. That doesn't make them the right programming environment for you now. And if you're thinking to yourself, what's the difference between a programming environment that simulates what happens at runtime and a debugger? You've got it. You don't need GDB looking at things from the outside. You need to be inside the running program, looking around and understanding the whole. Come on, using breakpoints is like monitoring traffic on the freeway by setting up a barricade. Look, the worst place that you can be in is to have tools that are adequate for the job. Human nature makes it almost impossible to make big changes unless everything is a complete dumpster fire. And only that motivates people out of their comfort zone to do something big. In Haskell in 2021, you have a lot of adequate tools for a fantastic language. To move Haskell forward, you need amazing tools, but how do you get there without something going incredibly wrong? What am I saying? Sorry, everyone, I can't do this. I love Haskell Language Server, and forgive me if I'm wrong about what happened, but what I saw from the outside was several groups trying to make the IDE experience of Haskell at least match other languages. And a few imploded around the same time, and this caused the crisis. And HLS, Haskell Language Server, was born out of the survivors. Now they were doing wonderful work and making great strides. Adequate means low motivation. Adequate means good enough for right now. Adequate means I have other priorities that need my attention instead. And then we have a situation where getting people to learn Haskell or adopt it for their company is painful and difficult because our tooling is adequate for current Haskellers doing what the current Haskellers are doing. That's not enough. Haskell was created to solve a problem in academic research, a proliferation of custom programming languages to explore ideas in the same arena, lazy functional programming. So much effort was going into trying ideas in one-off languages that almost nobody looked at. And much of the work involved was duplicated. You have a compile, you have a runtime, you got to reinvent these every single time. Haskell Language Server did the same thing with the IDE integration efforts. In both cases, it took recognition of a big problem to motivate the efforts. Do we need to wait for another crisis to motivate us to fix other parts of the system? Historically, some people have stepped up and tried to address the big problems or the big gaps in tooling, and they've gotten flack for their approach. This has happened with tools, it's happened with maintaining critical libraries, and on and on. In crisis mode, however, people align behind shared goals, and they let the criticisms fall off their shoulders because they have a clear purpose. Let's have shared goals and a clear purpose without needing a big crisis. Assume good intentions and collaborate, even when you disagree. We have chased people out of the community, and it's not okay. We're all people, even those I disagree with. And we need to establish the min bar of how we expect to treat each other up high, with dignity and respect. Speaking of bars, We need to set the bar for ourselves higher. It is okay to not have enough time and energy and fall short, but that's not the same as expecting libraries to not do what they need to do to be usable in industry or for real applications. And it's not the same as having tools and processes that need large, complex external systems to make them work in a reliable and performant way. Setting higher standards for ourselves is one way of lifting ourselves out of the pit of adequacy. It may take a while. It will certainly require a lot of work, but we need to decide that the future of Haskell is worth it. Are you convinced? Or do you secretly think that Haskell really is a toy language for researchers still? And that's where it will eventually end up. My dad did his PhD in Rutgers in 1968, and his work involved using a mainframe at the time, which meant punch cards. He still has them, and I used to joke when I worked at Quark that when a new programmer joined my team, I should hand them a big box of cards and say, your first task is to convert this to C. It would have been dumb, hazing behavior, for sure. But part of the reason it would have worked was that it was plausible. Punch cards were invented in 1880, and they were the dominant interface and storage medium for computers in the 20th century. Not only would you have been able to find companies using punch card systems in the mid-90s, the last company to manufacture the cards and the machinery around them only went out of business in 2011. What made this technology last so long, even after better alternatives were well established? It's the sunk cost fallacy, also known as the escalation of commitment. Would I continue to put investment into, for instance, a programming tool because of the investment I've already made in it, not because it's that investment stands on its own as the right choice? That's the fallacy I'm talking about. It's human nature. I mean, not only have I put my time and energy and maybe money already into that old tool, but I've developed expertise on how to use it. And who doesn't love to be an expert? I know I do. That was the thing about Turbo Pascal when I went to Carnegie Mellon. I had an expertise, and I love that feeling. The right choice is based on what gives the best results, ignoring the past, ignoring what you've already done. If a new tool or approach has more upside, I need to take the pain of changing and abandoning the non-transferable expertise and move forward. As my partner Ruth says, suck it up, buttercup. Back when version 1.3 of the Haskell report was published, it added monadic I/O, a revolutionary idea that has held up and influenced the world. In version 1.4, on the other hand, they tried list comprehensions generalized to arbitrary monads. That did not hold up. This is an illustration of the benefit of humility in our line of work. We need to be brutally honest with ourselves about our ideas. And that intellectual honesty is the most important thing to determining our success and our influence in the world. The values that the stewards and the benign dictators of Haskell have to prioritize reality over their own ego gratification is to be celebrated, and it needs to help guide us into the future. I don't feel like I'm being subtle about my vision for the future of Haskell being tied to tools and interactivity. But in case I am, my vision for the future of Haskell is about tools and interactivity. Just like way back in 1988, the interactive debugger enabled me to become a better programmer faster than I otherwise would have been, we need an interactive environment for Haskell worthy of existing more than 30 years later. An interactive debugger won't cut it. And an imperative style debugger doesn't work well for functional programming anyway. The strength of computers is their ability to simulate. Given a programming environment where the code you are looking at is being simulated, we can understand properties about it that can only be known when it's running. The environment can teach us about that code and help us understand at a much deeper level than is possible from reading a flat text file in a text editor, however tricky text editors may be to write. Text files are simply the wrong abstraction for storing computer programs. The relationship between functions is how they are called and how they relate to data structures, not which random file a programmer had open at the moment when they needed to write a new function. I am so glad that Haskell Language Server exists, and I hope that it is a vehicle for what I'm describing here. It is wonderful that I can now easily go from where I use a function to where it's defined. But I think this is a workaround for the problem about how we store and organize our code. Unison has reconceived some of these ideas, and I think their content addressing and immutable definition ideas are signposts towards the future of programming. Haskell has always been about showing the way forward, but GHC is such a behemoth that ideas that challenge such fundamental assumptions as the code is stored in text files cannot reasonably be explored with it, and that's okay. When someone shows amazing ideas in a separate language, we need to listen and figure out how it can show us the future of the language that we love too. Did you ever play technology leapfrog as a child? This is where one child has kept up with the existing technological advancements studiously, and the other child is denied access to them. And then the child who is denied access to them gets a cell phone and then looks at the other kid who has a landline and wonders why they even bought. I think I'm not quite getting that right. But we're back to the sub-cost fallacy again. When there are already big investments in infrastructure based on old technology, we want to add to those investments instead of doing the more costly but long-term, more efficient work towards newer, better infrastructure. Just like the adoption of Visual SourceSafe back when I worked at Quark, we need to move with purpose towards the investments that will give us more long-term efficiency. I don't want a better or more integrated imperative style debugger for Haskell. I don't even want one that understands lazy functional programming better, but does it in the style of existing tools and ideas. What Haskell needs and deserves is to leapfrog over those ideas and figure out what is next, what is unique to what we're doing. One of my biggest frustrations when I came to Haskell was going back to printf debugging again. I want to see and feel functions. I want to understand how they relate to each other. I want to be able to watch the data flow through them. I would love to have visualizations for different abstractions like monoids, applicative, monads, lenses, traverse. Make it easier for me to understand not only how they work, but how to use them. I should see performance bottlenecks. I should watch funks being created and consumed, and it should be awe-inspiring when a garbage collection pass comes through. It would not be in real time, that would be meaningless. It would just go by too fast, but relative speeds should somehow be preserved, maybe logarithmically, whatever, so that I can make informed decisions about where to spend my effort in the code. If the quick check style data is going through and it causes an exception, that should feel like a big deal. And I need control over this environment. I can pause, rewind, loop a period of time, save inputs that cause issues. I can zoom in and see functions as boxes or tubes, and then go in and see their guts, and then go in and see those guts, all the way to core, all the way to C++, all the way to assembly. There should not be a black box. Nothing bothers me more than a black box. I should see the workings of our runtime system and see how it's interacting with my code. Is this a set of dissertations? Is it you working with others in the Haskell community right now, and even more who aren't, figuring out what this looks like, what it feels like, how we make it interact, respond, react, enhance? We need more people to work on these problems than we have in our community. We need more ideas and we need more perspectives. If we're doing cool, amazing, groundbreaking things, they will want to help, and we need to welcome them. Come be part of the Haskell community. where we help and encourage each other. And we want everyone to find purpose and joy. People pick on movie user interfaces, but they are aspirational, and we need more aspirations. Shed complacency. Stop being happy with our tools. We are using 20th century tools, and we haven't been in the 20th century for over 20 years. Even I, as aged as I am, will soon cross the threshold where I've lived more years in the 21st century than in the 20th. Not enough? Okay, let's back up to the big problems in our world right now. Climate change, pandemics, inequality, natural disasters. How can we solve them? Software is eating the world, which means that the way that we develop software is the linchpin for enabling experts to find solutions. If we can significantly shorten the cycle between having an idea and determining if it can work, that will free our creativity for fixing those immediate problems and the ones that will come at us in the future at an ever-increasing rate. We won't be the ones solving the problems for the most part, but we can be the enablers. We can avoid being the bottleneck. The reason I wanted this job and the reason that I wanted to talk to you today is that I believe Haskell is the right way forward. Strongly typed, lazy, functional programming in Haskell couples the best ideas from research with a compiler and runtime ready for production use. We're an open source project staffed largely by volunteers, and that has been one of our strengths that have gotten us this far. It also explains why our tooling is where it is. The emphasis has been on research and making everything work right, not making it pretty. We need to leap out of this hole that we've made for ourselves. Haskell deserves not just to be mainstream, but pivotal. Give programmers a better experience than anything else out there by orders of magnitude. The ideas we've generated in this community have changed the landscape of programming languages already, and we can do it again and again. You can change the world. Not just the Simons, Phil, Leonard, Richard, the names that you recognize and expect great things from, but you. It isn't about having the most brilliant idea out of the gate. It's about coming up with the ideas, trying them out, learning from them, and doing it again and again. We need to make that easier. I can't even tell you which iteration of this talk I'm giving today. It's been so very many. I'm exhausted. I'm exhausted and I'm excited because I cannot wait to see what you will come up with. Yeah, so you gotta save our future, right? Okay, so I understand that we're supposed to go to like a Q&A session now. Okay, sure, like a time traveling Q&A session. That's a great plan. What are a few paradoxes amongst friends, right? I'll see you over there.
Thank you so much, Andrew. And for anyone watching, if you look at the chat log, we have a link to the spatial chat where I hope you'll join us.